Hi everyone, today I will introduce Excel Solver, which is one of the powerful and useful tool in Excel. In this class, I'll explain a very simple example to explain the usage of Solver. Before starting this, I'll explain the three basic differences between goal-seek and Solver. In goal-seek, objective function has to be assigned a value, whereas in a solver, we can maximize, minimize, or set a value for the objective function. The second difference is, in goal-seek, we can adjust only one variable to get the desired objective, whereas in solver, we can use a number of variables. The last point is, in solver, we can add many constraints, which is not possible in goal-seek. Let me explain a very simple example to find the roots of a quadratic equation using Excel solver. In the previous class, we already solved the quadratic equation using Excel's goal-seek. So today I'll explain how to solve a similar problem using Excel solver. Excel solver will give more accurate answer than goal-seek. I have the quadratic equation of this form: ax square plus bx plus c is equal to 0. The constants a, b, c, I have given values here. A is 2, b is minus 6 and c is 2. Now I'll keep the objective function in this cell and the solution for x I am assigning in this cell. So objective function is a into x square plus bx plus c. So I need to write the objective function here equal to a, that is this cell value, multiplied by x square plus b is here, this cell you can select, multiply by x plus you can select c. So this is your objective function. So now you are getting 2 as the value. So because x is 0, x I have not assigned any value, x is 0. So when x is 0, first two terms will become 0 and c value, which is 2, that will be the right hand side. So what I need to do is to minimize this objective function. So my intention is to make this cell 0. Now to make this cell 0, what should be the value of x? In Excel, we need to separately enable the solver. It will not be readily available on the ribbon bar. So what we need to do is, you can right click on the ribbon bar and then click on customize. So here you have to select add-in. Then in the Excel add-in, you can go and select solver add-in. So I already selected the solver add-in. So once you select the solver add-in, it will be available on the ribbon bar under the data tab. So I am getting solver here. So if you are not enabled, you cannot see that solver under the data tab. So first you go for solver, select the solver, then you have to set the objective. Your objective is in this particular cell, so you can click on that cell. So that is your objective function, where you have a formula placed there. Wherever you keep the objective function, there you should have a formula. Now you have three options, whether you can maximize this objective function or minimize or set a value. A particular value can be given. Here I need to set this to 0. Then you need to adjust the value. So you can select a single cell or number of cells. So here I have only a single cell to adjust the value. So I can click on this, select this cell. By adjusting this value, I have to adjust the right hand side to 0. That is, objective function should be 0. So you have set the objective function and you have set the changing variable cell. Now after this, if you have any constraint, you can add the constraints here. So I don't have any constraint to add. So now you have to select the solver. So there are three different methods: GRG, nonlinear, simplex LP, and evolutionary. So GRG nonlinear is for nonlinear functions, and simplex LP is for linear functions, and evolutionary is for non-smooth functions. Evolutionary is used when your objective function involves non-smooth functions. Most of the solution you can do by GRG nonlinear. Now you can solve it. So I'll go for solving this. Solver found a solution. So solution has come here. You can click OK. So I got a solution here. This is almost 0. It is to the power of 10 raised to minus 6. Now this is a quadratic equation. I got a one solution, that is 0.382. So one solution you got. Now second solution you should get by trial and error. So I can check with the different values here, and you can find out a sign change for the function, that is the right hand side. When that sign change happens, nearer to that there will be another root. So you can try with the 1, 2, 3, 4 positive integers and negative integers minus 1, 2, 3, etc. So wherever two consecutive values, when you get a sign change, a root lies between that two values, and you can start with any one of that boundary values. I'll check with the 1, you are getting minus 2. When it is 2, it is minus 2. When it is 3, it is plus 2. So between 2 and 3, there is a sign change. When it is 2, the value is minus 2. When it is 3, the value is 2. So there is a sign change for the function between 2 and 3. So between 2 and 3, there is another root. We have already got another root, which is 0.382. Now another root lies between 2 and 3. So when it is 2, it was negative. When it is 3, it is positive value. So there is a root between 2 and 3. So I'll keep this as 3 or 2. And then you can go for solver. Now solver already, we have set that cells. Okay, objective function you have already selected, and this is also selected. So you need to only just click on the solver. So that will give a root of that. Solver found a solution. Now you click OK. So you got that second root. So between 2 and 3, you have this 2.618. This is another root. So you have 0.382, which is the first root, and 2.618 is the second root. So you got both the roots of the equation. If you forget a first value, you can try with a 0. Then go for solver, solve it. So that will give the first root. Okay. So if you try with a 2 or 3, you will get the another root. So this is a second root. So this way you can find out both the root of the quadratic equation using the solver. So this is a very simple example where a solver gives a quick solution. There are a lot more the solver can do. In the next class, I'll explain how to maximize the profit in sales. Thank you for watching, and we'll meet you in the next video.